coordination compounds. Before exploring this topic, I'd like to explain about the three types of salts. Take down. Simple salt, double salt, then complex salt. The simple salts are like NaCl, sodium chloride, sodium sulfate, etc. Double salts like more salts, that is ferrous ammonium sulfate, FeSO4, NH4 twice SO4. This is called double salt. And complex salt, for example potassium ferrocyanide, K4FeCN 6 times. In the case of simple salt, when we ionize this, we are able to get in the aqueous solution, that is Na plus Cl minus, that is cations and anions. They are separated as cations and anions. Positively charged ions are cations, negatively charged ions are anions. And similarly, in the case of FeSO4, NH4 twice SO4 in aqueous solution, they get ionized like Fe2 plus SO4 2 minus plus NH4 plus, that is 2 moles of ammonium plus SO4 2 minus sulfate. It's a divalent anion. So all these ions are separated. But in the case of a complex salt, they get ionized like 4K plus and these FeCN 6 times together as complex ion with 4 valency, 4 minus. This is called complex ion. It is because there is a coordination bond developed between iron and this 6 cyanide molecules or anions. So it is because of its complexity, it was called a complex salt. It was not isolated as Fe2 plus, Cn minus, K4 plus, etc., 4K plus. Instead, they form as a group and they are available as complex anion and a cation, and that is why they are called complex compounds or complex salts. So this complex salts was the basis of this coordination chemistry. Now let me talk about the type of bonds, chemical bonds. The bonds can be classified into 4 types. One is the famous covalent bond, another is ionic bond, and you have metallic bond, then coordinate bond. Covalent bond, it is because of the combination of electronegative atom and electronegative atom. Ionic bond, that is, it is because of the combination of electropositive atom and electronegative atom. And metallic, because of the combination of electropositive atom and electropositive atom. Whereas in the case of a coordinate bond, there will be a donor and there will be an acceptor. Donor, D stands for donor, A stands for acceptor. A pair of electron is donated by the donor. We know for any bond, chemical bond, minimum 2 electrons are required. Either these 2 electrons should be mutually shared, as in the case of covalency. So here mutual sharing of electron takes place. mutual sharing of electrons. Here it is electron transfer, E transfer. Okay. For instance, let me consider chlorine. It's a non-metal. Another chlorine, non-metal. It contributes one electron and this chlorine contributes one electron. They mutually share and forms a bond. So that is called covalent bond. So covalent means mutual sharing of electrons. So in this case, when they are broken, when they are cleaved, homolysis takes place. Homolysis means even cleavage. That results chlorine with free radical. So they result free radicals. What are free radicals? Highly energized atoms. An atom with odd electron is called free radical. There is no charge involved, but they take the odd electron. That is why they are highly energized. This kind of reactions will take place in presence of sunlight, and that is why it results in homolysis, resulting free radicals. And both participating atoms are electronegative. You should understand the term electronegativity. Before that, let us analyze the electropositivity. Sodium is there, it has got 11 electrons and 11 protons. So here, this 11 electrons sodium, it can give out one electron, being a metal, becomes Na plus. So this becomes 10 electrons. In this case, in terms of electronic orbit, that is 2 electron and 8 electron and 1 electron. So here 2 and 8 only. So it is more stable because of the octet rule. So this is more stable, and because of octet rule. Octet rule means when an atom has 8 electron system, they are more stable. That is called octet rule. So thereby it has got 8 electron system in the outermost shell, and that is why Na plus is more stable than sodium in the ground state. So naturally it releases one electron. This kind of releasing the electron is called electropositivity, and that is a very metallic behavior. So what do you mean by electropositivity? Electropositivity means electron releasing tendency. So metals have this behavior, whereas non-metal, they withdraw the electron from the bonded pair. So electron releasing tendency is called what? The electropositivity. Whereas in the case of chlorine, it can take the electron to become Cl minus. Are you able to follow? So this tendency of taking electron, that is withdrawing electron, is called electronegativity. So what is electronegativity? Take down. Electronegativity means electron withdrawing tendency. Withdrawing tendency. So this is the metallic behavior. What this electropositivity is? The metallic behavior. Whereas this one is non-metallic behavior, and that is why non-metals behave in this way. That is why a metal and non-metal can combine to form a compound. For example, sodium and chlorine. Sodium is metal, chlorine is non-metal. So they can form NaCl. So in that case, it is NaCl. So here they share, but during ionization they split. that is heterolysis takes place. So it takes the electron of sodium also. Okay, so chlorine becomes Cl minus, sodium becomes sodium plus. So this kind of tendency is available in ionic valency, ionic bond, and that's why it's also called the electrovalent bond. Electrovalent bond. Okay, so here one is electropositive, another is electronegative. So they combine and there is an electron transfer during the cleavage. So here heterolysis takes place. Whereas in the case of metallic, both of them are electron releasing tendency. So electropositivity plus electropositivity, that leads to metallic bond. And what about this coordinate bond? A pair of electron is donated. Okay. Let us consider the coordination bond, coordination compounds. According to Werner's theory, he suggested that is there is a central metal atom. There will be a central metal atom around which electrons are present. I mean not electrons, ligands are present. So each metal has, this central metal has two types of valency, primary valency and secondary valency. The inner sphere is coordination sphere, the dotted line. Inner sphere or coordination sphere. And it is not ionizable so easily. Whereas the outer sphere is ionizable. So this is called ionization sphere. Ionization sphere. So there exist two types of valency, primary valency and secondary valency. Primary valency, secondary valency. So here the primary valency is referred to the oxidation state of the central metal atom. Oxidation number of central metal atom. Secondary valency nowadays is represented as the coordination number. Coordination number. In fact, this secondary valency is ionizable, whereas primary valency is involved in the inner coordination. So that is why this is not so ionizable easily, whereas the outer is ionizable. And that is why, now let me explain one important thing. He was able to explain the behavior of the cobalt chloride with the 6 moles of ammonia. This is the different types of complex and here non-ionizable. Non-ionizable inner sphere, that is coordination sphere. Okay, that is secondary valency. Secondary valency. Here it describes about ionizable valency. And here when we treat with silver chloride, that is how many silver nitrate, how many silver chloride is obtained. Okay, so the number of chlorides to form silver to react with the AgNO3, so that you will get AgCl. Now let me take the first complex, COCl3, cobalt, carbon, not carbon, C and small letter O. Okay, you should not write C capital O. Okay, that becomes carbon monoxide. So CO means cobalt. So cobalt chloride, trichloride with 6 ammonia molecules. And there is another type, COCl3 with 5NH3. And another one, COCl3 with 4NH3 and COCl3 with 4NH3. Same. Now here in the non-ionizable valency, 6NH3 is there. Ammonia is within that. And the 3 chlorides are outside the sphere. They are they are ionizable outside the sphere, and thereby they can form 3 AgCl because they are freely available. Now this can be represented as, for example, this NH3, 6NH3 here, it is available as, that is CO, okay, and then NH3 6 times, and outside the sphere it has Cl, okay, so it can be represented as CO NH3 6 times and Cl3, okay. And that is why all these 6 NH3 is involved in the coordination sphere. And the secondary valency, that is a primary valency which is outside the coordination sphere, that is ionizable, that can easily react with AgNO3 to form AgCl. So that is why this Cl3 is available outside the coordination sphere. Are you able to understand this? So let me explain this in such a way. For instance, let us have CO NH3 6 times Cl3. It reacts with AgNO3, silver nitrate. Now it will involve 3 moles of silver, so that you are able to get 3 AgCl. So as precipitate. Now this clearly indicates that these 3 chlorine atoms are outside the coordination sphere, and that is why they are ionizable and form 3 moles of silver chloride. Do you understand this? Are you able to follow? And it means 6 NH3 is available inside. So here CO NH3 6 times, okay, they are within that along with minus, okay, along with plus charge. Are you able to follow? So they are tightly bound because of the coordination sphere. Whereas this is ionizable one, and that is why it has come out of this silver. Come out of this complex ion to react with the silver to form 3 moles of silver chloride. Are you able to understand this? Right. Now let me explain this one. In this case, 2Cl is available outside. What does it indicate? You will get AgCl. So in that case, how will be the molecule? That is CO is there, and here that is 1Cl has come inside, replaced by 1 ammonia. So 1 Cl has come inside actually. So CO, Cl, and then 5NH3. Okay, 5NH3, 5 times of the remaining is outside, Cl2. Do you understand? So 2 Cls are available. So how will be the coordination sphere? This square bracket represents the coordination sphere. So CO, Cl, NH3, 5 times. So this is a coordination sphere, and that is the inner sphere. They are not ionizable. It means we have the ionizable chloride. 2 chlorides are available. So they are here, and that will combine with the silver nitrate to form 2 AgCl. From this you can easily find out. So from this experiment you can easily analyze how many chlorine atoms are outside the coordination sphere based on the number of moles of silver chloride. Do you understand this point? For example, in this case here, that is we have 1 Cl resulting 1 AgCl with the 4 NH3. So here that is the compound will be CO, NH3 4 times with the 2 Cl, Cl2. So this is a coordination sphere. Are you able to follow? And how we can write down the compound? I am writing in red letter in this. CO and then NH3 here 4 times. Okay, so CO, NH3 4 times, and Cl2. So Cl2 is inside. Outside the coordination sphere there is only 1 chlorine. That is why that chlorine combines with the AgNO3 to give 1 AgCl. Do you understand? And what about the last one? The last one has, that is 4 NH3, that is CO, NH3 4 times with the 2 Cl. Okay, and 1 Cl is available. Okay, so we can even have 1 Cl, NH4Cl2, the same is repeated here it seems. Okay, otherwise we can put, that is the chlorine itself, nothing is available, we will make no chlorine is available, so no precipitate. So in that case all the NH3, this can be 3 times and you can put 3 times. It means all the chlorines are available inside the coordination sphere and nothing is left out. So it means a neutral coordination compound is available, a complex compound, and no chlorine is available externally, and that is why this salt is unable to get the silver chloride. It will not react with the silver nitrate because all these 3 chlorines are safely protected by the inner coordination sphere. Are you able to understand this point? Now let me explain about this. It means, I was talking about this inner sphere, outer sphere. Let me explain in a different way. For example, you have the central metal atom and you got the octahedron arrangement. Cobalt is at the center. You have one NH3 here, another NH3 is here, another NH3 is here, another NH3 is here. So they are It is cobalt is centrally located, and that's why it's called central metal atom, and above and below the plane. So this is square planar bipyramidal structure, that is octahedral structure. Okay, octahedral structure. So you have NH3 here, you have NH3 here. In this case, all these are occupied by ammonia only. Okay, so this is available inside the coordination sphere. Outside the coordination sphere, you have Cl. How to represent that? And this is loosely held. Okay, let me take it like this. Are you able to follow? And another, let me put Cl. Now do you understand this? And this is simply represented as CO, NH3 and 6 ligands. They are called ligands. So these 6 ligands are surrounding the central metal atom cobalt within the coordination sphere, and outside the coordination sphere you have Cl3. Are you able to follow? So this is the way we can represent the coordination compound. Now this can be named according to the latest IUPAC nomenclature system. For example, the cation should be named first. First of all, we should be able to identify the nature of ion of complex. So here it is a complex ion of, when we ionize it becomes plus and this is minus, is it not? So let me put with another, so it has got minus charge and this is 3 plus, is it not? Chloride is monovalent and that is why 3 valency, so 3 into minus, 3 minus, and this is 3 plus. Okay, and if it is 3 plus, and what about the, this is 0 because it's a neutral molecule. Ammonia is a neutral molecule, and the cobalt, now it has 3 valency, that is always represented by Roman letter. Now this can be named as first complex ion followed by anion, that is first cation followed by anion. If the complex ion is available as cation, it should be named first. If it is available as the anion, the cation should be named followed by the complex ion. Okay, so in this case complex ion comes first, and that is why we name like this, and within that the ligands should be given preference. So how many ligands are there? 6 ligands. Okay, what are ligands? These are the anions or neutral molecules surrounding the central metal atom, coordinated to the central metal atom. Okay, and that is why they are called ligands, right? So these ligands, how many ligands are there? 6 ligands. So 6 means hexa, and for amine it should be called amine, double M-I-N-E, for ammonium. So hexaamine, take down, hexaamine, and what about this cobalt? It should be called a cobalt as such, and then its valency, that is its oxidation state, should be mentioned as the Roman letter 3. So hexaamine cobalt 3, and then followed by anion. Anion is chloride, so put chloride simply. So this is the way you have to give the nomenclature. Okay, hexaamine cobalt 3 chloride. Okay, now can you draw the similar structure with 5NH3 and 1 Cl inside and 2 Cl outside, and what could be the name? Can you guess? Try.